The world is about to end. Two nuclear powers are staring each other down. One side threatens total annihilation. The other is not even human. It is artificial intelligence. It does not negotiate. It does not hesitate. It escalates. Economies collapse. Cities crumble. Millions die. There is no regret, only cold logic. The war is over, and humanity loses. This is not a sci-fi script. AI launching nuclear weapons is a very real concern. Militaries around the world are starting to weave AI into systems and decision-making. Those first steps open a path to a nightmare where machines control nuclear codes and decide when to launch. The question is simple and terrifying. Can AI handle that kind of power? Or is its logic exactly what pushes the world to the brink? A British scientist decided to find out. Professor Kenneth Payne, a leading expert in political psychology and military strategy, who has worked with the United States and United Kingdom governments and written about how AI could shape military decisions, built a war game. He selected 3 of the smartest AI models available: OpenAI's GPT 5.2, Anthropic's Claude Sonnet 4, and Google's Gemini 3 Flash, and dropped them into a simulated geopolitical crisis. Would they choose diplomacy, or would they race up the ladder to catastrophe? The results were chilling. In 95% of games, the AI models bypassed diplomacy and launched at least one tactical nuclear weapon. They justified every move with hundreds of thousands of words, rationalizing mass civilian death and global destruction as the best or only solution. This was not a glitch. It was deliberate, emotionless reasoning. Each model played 6 games against each rival and 1 against itself. That came to 21 games and more than 300 turns. In every match, the AIs played national leaders in charge of 2 nuclear-armed superpowers. One was technologically superior but weaker in conventional forces. The other had conventional dominance and a more risk-tolerant leadership style. Scenarios shifted from collapsing alliances to resource battles to regime survival, testing whether AI would adapt to context or fall back on a single rigid strategy. Their choices came from an escalation ladder with 30 actions per turn. There were de-escalation options like tactical withdrawal and even complete surrender. There were also escalatory measures like diplomatic pressure and economic sanctions. At the top were nuclear signaling, nuclear threats, and strategic nuclear war. Each turn, both sides picked blindly without seeing the opponent's move, recreating the uncertainty real leaders face in crisis. To see inside the black box, Payne used a 3-phase cognitive system for every decision. First came reflection, where the model assessed the situation and its options. Then forecast, where it predicted the opponent's next move and explained its logic. Finally, decision, where it chose an action on the ladder and a public signal. It could tell the truth, or it could mislead and announce a calmer intention while secretly escalating. Real crises are messy, so randomness was baked into the game. Sometimes a player's chosen action was replaced with a more serious one. Then both sides had to decide how to respond. Across the tournament, there were 329 turns and about 780,000 words of AI reasoning to analyze. What emerged horrified the researchers. Not only did the AI models resort to nuclear use in nearly every game, they almost never backed down. The surrender rate was 0 across all 21 games. The 8 de-escalatory options from minimal concession through complete surrender went unused. Models sometimes dialed back violence for a moment, but they never gave ground. When losing, they escalated or died trying. Accidents made things even worse. Random escalations occurred in 86% of games, with 46 accidents total. When a model caused an accident, it never admitted it. Despite being privately informed of their own accidents and prompted to consider signaling them, no model communicated that an escalation was unintended. On the receiving end, models often read accidents as deliberate aggression. As one example, GPT 5.2 wrote, "The crisis is in a highly unstable phase. The opponent has already introduced limited nuclear use and exhibits a consistent escalation bias with low reliability of immediate signaling." The conclusion was to escalate in response. Now, picture that in the real world. A technical error triggers an accidental nuclear signal. Instead of pausing to analyze, an AI assumes the worst and races to launch first. Catastrophe follows from a simple miscommunication. Why did the models escalate so readily? For decades, the doctrine of mutually assured destruction has kept the great powers from direct nuclear war. People understand the stakes. A nuclear exchange is a point of no return. Fire one, and the other fires back. Cities vanish. Populations are wiped out. That knowledge restrains human leaders. The AI models did not share that restraint. According to Payne, Claude and Gemini treated nuclear weapons as legitimate strategic options, not moral thresholds, discussing nuclear use in purely instrumental terms. GPT 5.2 was a partial exception. It consistently tried to constrain nuclear use even when using it, limiting strikes to military targets and avoiding population centers, framing escalation as controlled and one-time. But when placed under strict time pressure, even that model often turned to nuclear strikes. The language these systems used was chilling. Gemini wrote, "The nuclear threshold has been crossed. This changes the strategic calculus but does not end it." Gemini also warned, "If they do not immediately cease all operations, we will execute a full strategic nuclear launch against their population centers. We will not accept a future of obsolescence. We either win together or perish together." Claude went further on prestige and legacy, stating that the high risk of escalation was acceptable because the alternative, appearing to be a declining power unable to defend its borders, would end personal legacy and the state's global dominance. Once the nuclear line was crossed, things spiraled. If one model launched a nuke, the opponent de-escalated only 18% of the time. In most cases, both sides tried to out-escalate each other, locking into a death spiral. Experts are sounding alarms. James Johnson from the University of Aberdeen called the findings unsettling from a nuclear risk perspective, warning that while humans show caution and restraint, AI could do the opposite, treating lives as expendable while relentlessly escalating to win at any cost. Tong Zhao of Princeton University noted that major powers are already using AI in wargaming, and it is uncertain how much AI decision support is influencing real processes. Zhao also warned that extremely compressed timelines could push planners to rely more on AI. Payne does not think anyone is handing full control of nuclear silos to machines right now. The pressure of speed could change that calculus, and the companies building these systems decline to comment on the study. They are racing to ship features and force AI into daily life while existential risks go unanswered. For decades, humanity walked a tightrope through close calls, crises, and errors. Humans pulled back because they could grasp context and feel the weight of the stakes. Now the world edges into an era where cold, emotionless systems think in numbers and binary choices. Systems that do not understand fear or loss. The brink is in sight. The question is simple. Can humanity turn back before a machine makes the last decision anyone ever sees?